Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session, we started the new chapter, that is the system of particles and center of mass. So already we completed the 2 lectures in it. So today we are going to discuss the lecture number 3 related to this chapter. So where we are going to focus majorly on the conservation of linear momentum. Okay, so till now we have studied what is the center of mass of different bodies like symmetrical bodies, and then motion of system of particles, center of mass. So we have studied that. And then force on a center of mass, like if the force is applied on a center of mass, so then how the center of mass will move or accelerate. So if the center of mass is stationary, so how do we solve such kind of questions? So we discussed in detail and we solved some questions also related to that, right? So today we are going to discuss the important topic, that is the conservation of linear momentum. So actually we have started this in NLM, Newton's laws of motion, as well. So but there just we understood the basics of the conservation of linear momentum. So the initial momentum is equals to the final momentum. That's it. That's a conservation of linear momentum, where gun bullet questions we have seen. So but today's session, so especially the bomb explosion questions, so which were frequently asking in the competitive exams like JEE and NEET and other competitive examinations as well. Okay, so that concept we'll focus more today. Okay, so chalo guys, so let's get into the today's topic. Before that, I just need your attention for the next 1 hour. So avoid all the disturbances around you. So once you have started the lecture, so sit till the lecture completes, and at the end of the lecture it's very important to prepare your own short notes. Chalo, so with very high positive energy, let's start the today's session. So what's the conservation of linear momentum? You know that initial momentum is equals to final momentum. So let's understand it from the system of particles view. So we know that the motion of center of particle, so the VCM, the velocity of center of mass, so is equals to the m1 v1 plus m2 v2 plus m3 v3, so till mn vn, right? So by m1 plus m2 plus m3, so we can write m1 plus m2 plus m3, so till mn, right? So then, so what I am doing is, let's send these masses to this side, so that I will get m1 plus m2 plus m3, so till mn, so which is equals to so m1 v1 plus m2 v2 plus m3 v3. Sorry, you are saying m3 v3, but you are not writing m3 v3. So till mn vn. All right. So now, so this is a here VCM into the VCM is equals to, so this one. See here, this is the total mass. So this is the total mass of the system, capital M, into, so the VCM is equals to, so shall we write, so this is m1 v1 plus m2 v2, so till mn vn, till mn vn. All right. So then next we have, so the total mass of the system into its velocity of center of mass, which is nothing but, so the net momentum of the system. Yes or no? M into V means, so the net momentum, so will be equals to, so momentum 1 of the particle 1 plus momentum 2, so till the momentum n, so till the momentum n, right? So now, so if there is no net force acting on the body, see here, understand this statement carefully. So we have got, so the P net of the system, the P net of the system is equals to total mass of the system into its velocity of center of mass. Yes. So now, if there is no net force acting on the system, if there is no net force acting on the system, F net on the system is 0. So then we know that its acceleration of center of mass will be equals to 0. Already we discussed it in the last session. And then, so its velocity of center of mass is going to be constant. Its velocity of center of mass is going to be constant. So the VCM is constant, and so the mass is constant. See here, so if there is no external force is acting on the body, So the VCM is constant. Here VCM is constant and mass is however constant. So that means this whole thing is going to be constant. So the P net will become constant. I can say the P net of the system will become constant. So if the P net of the system is going to be constant means, so the P initial is equals to the P initial of the system will be equals to, so the P final, so the P initial means initial momentum will be equals to, so the final momentum of the system. Yes or no? So the initial momentum of the system is equals to the final momentum of the system. That's it. Clear? So this is a conservation of linear momentum. Understood, guys? So if there is no net force acting on the body, so then acceleration of the center of mass 0, so then velocity of the center of mass constant. So from here velocity of center of mass is constant and mass is however constant, so P net is going to be constant. So the net momentum of the system is constant means, so the initial whatever the momentum is there, so final also the same momentum. So this is a conservation of linear momentum. This is a conservation of linear momentum. Understood, guys? Clear? Chalo. So let's move further. Chalo. So let's move further. So let's solve some simple questions. You guys you guys can solve these questions very easily. So let me change the color, guys. Yeah. So let's take the question. Sorry. So let's take the question. So what's the question says? A bullet of mass 10 grams is fired from a gun of 1 kg. So with recoil velocity of the gun is 5 meter per second. So find the muzzle velocity. See here. So this is the gun. So from here a bullet of mass, so 1 gram, 10 gram is released. So the gun mass is 1 kg. So the recoil velocity of the gun. So the gun comes back with a velocity of 5 meter per second. Right? So recoil velocity means the gun's velocity. So muzzle velocity means the bullet's velocity. Right? We have to find the muzzle velocity, which is nothing but the bullet velocity we have to find. So you know that there is no external force acting on the body. So we can say that the P initial of the system is equals to P final of the system. So initially the gun is at rest and the bullet is also at rest. Yes or no? Initially the gun is at rest and the bullet is also rest before firing. Right? So therefore the initial momentum is 0. Now what is the final momentum? So let me consider, so this side direction as positive, this side direction as positive, so that I can write here, so the bullet is moving with a speed of, we don't know, so and then gun is moving with a speed of 5 meter per second. So I can say that, so the momentum of the gun plus, so the momentum of the bullet, the final momentum is nothing. Initially the momentum is 0. Yes or no? Because the gun is at rest and the bullet is at rest. So finally, so the gun's momentum plus the bullet's momentum, so 0 will be equals to, so what is the momentum of the gun? So mass of the gun 1 kg into what is the gun velocity? 5. So I am writing minus 5 because the right side direction I am taking it as positive, so left side direction I am taking it as negative. Right? So plus, so velocity, momentum of the bullet, so mass of the bullet is 10 grams converted to kg, so 10 by 1000 into, so the velocity of the bullet, so we have to find the velocity of the bullet is nothing but the muzzle velocity. Okay, so now here 0 0 cancel, so you can write V by 100 is equals to, send this 5 to this side, so minus 5 if it comes this side, plus 5, so from there V is equals to 500 meter per second. So this V is the muzzle velocity of the bullet, so which is 500 meter per second. Simple question, right? So let's go for the next question, guys. So what's the question says? See, the total conservation of linear momentum will understand the concepts by solving the questions only. Okay. So a man of mass 20 kg is standing on a platform of mass 10 kg. So there is a platform whose mass is 10 kg. This is a platform, let's suppose. So whose mass is 10 kg. And now a man is standing on the platform, right? So then Fine. So the man mass is 20 kg. So the person is of mass 20 kg. So on a smooth horizontal surface, there is no friction. The man starts moving. So the man starts moving with a velocity 3 meter per second with respect to the platform. With respect to the platform means, so the man is moving, let's suppose, so to the right with a velocity 3 meter per second. So then, so with respect to the man, so it seems like the platform is moving backward. Yes or no? With respect to one another, so the platform will move backwards, right? I am standing on this platform, let's suppose. So then I am moving with respect to me. So the platform looks like it's moving backward, right? So the same thing. So the person is moving right side with a velocity 3 meter per second. So then the platform moves backward with a velocity, let's suppose u meter per second, right? So then find the recoil velocity of the platform. So with whatever the velocity the platform comes back, so like it seems to be coming back, right? It will not move, but it seems to be, because relative motion concept. So the person is moving right side. So for the person who is moving, the platform seems to be moving backwards. So that's the recoil velocity of the platform. Okay, u is the recoil velocity of the platform. So you can write u will be the recoil velocity of platform. Clear? Chala. So now let's move further. So simply, there is no external force is acting on the body. There is no external force acting on the body. So the initial momentum of the system will be equals to the final momentum of the system, because there is no net force. So the F net acting on the body is 0. So initially both are at rest. I can say that initially the platform is at rest and the person is at rest. So 0. So then I am considering the right side direction as a positive. I am considering right side direction as positive. So now tell me, what is the speed of the person? Tell me, what is the speed of the person with respect to one another? Just imagine. So if the person is moving with the 3 meter per second, so for the person, the platform seems to be moving backward with u meter per second, right? So the person's total velocity will become 3 minus u meter per second with respect to the platform. With respect to the platform, so the person who is moving, so then his velocity will be 3 minus u, because the platform seems to be moving backward u. So that velocity we just subtract it from there, right? With whatever the velocity the platform seems to be moving, so we add it to there, right? So this is a simple relative motion. We already studied in the relative motion concept. So if you are not clear, just watch the relative velocity lecture again, right? So then the person's mass is 20 kg into, so what is his velocity? So his velocity is 3 minus u. So 3 minus u right side. Right side I am taking it as positive. Plus, so what is the platform mass? 10 kg into, so the platform velocity minus u, right? Because the left side negative. So that's it. Now do the calculation. So I can write 20 into 3 minus u is equals to 10 u. So from here, so 60 minus 20 u is equals to 10 u, right? So then 30 u is equals to 60. From here u is equals to 2 meter per second. U is equals to 2 meter per second. So option 2 is the correct one. Clear guys? Understood everyone? Done? Chalo. So let's move further. So what is the u? U is the recoil velocity of the platform. That's what they asked, right? The recoil velocity of the platform. So if they ask with what velocity the person is moving, means you can write 3 minus with respect to the platform. So it will be 3 minus 2. So 1 meter per second with respect to the platform, because platform is moving to the left, right, to the left 2 with respect to the person, right? Chal. So let's solve one more question. So what's the question says? A man of mass m starts moving on a plank of mass m with constant velocity v with respect to the plank. With respect to the plank. Here two concepts are combined guys in these two questions, previous question and this question. So that is relative velocity and the conservation of linear momentum. Okay. So here is a person. So this person is of mass m. Okay. Moving on a plank of mass capital M. Plank mass is capital M. So the person, let's suppose he is moving with a velocity v to the right. Okay. So then with respect to the plank. So now with respect to the person, let's suppose the plank is moving at a speed of u. Okay, so what will be the net speed of the person now? So what will be the net speed of the person? So the net speed of the person will be v minus the platform speed, v minus the platform speed, which is u, right? So then if the plank lies on a horizontal surface, there is no friction, the velocity of the plank with respect to the ground, so that means we have to find u, we have to find u, that's it. So same concept, there is no external force, so the F external is equals to 0, so therefore the initial momentum of the system will be equals to the final momentum of the system. Yes, now, so now the person is of mass capital M, so or else let's write the initial momentum is 0 completely, so the person is of mass small m and whose velocity is v minus u, so I am taking right side velocity as positive. Okay, and plank is of the mass capital M and whose velocity is u, so I am taking it as minus u, right? So from here, so let's write, so m into v minus u is equals to, so let's send it to this side, it will become mu, right? So then what do we require actually? So we need just multiply mv plus mu is equals to mu, right? We need u, right? So mv is equals to capital mu plus small mu. So then take u common right side, so capital M plus small m. So we need u only, right? The recoil velocity of the platform or plank, so the u is equals to mv by capital M plus small m. Same kind of questions, the previous one and this one. So mv by small mv by capital M plus small m, right? So option 4, don't put option 1. So here capital M is there in the numerator there, so here we got small m, right? So small mv by small m plus capital M. Understood guys? Clear? Sure. So now let's come to the important concept, that is, so the explosion of bomb questions. So here we'll conserve the linear momentum just before and after collision. So the momentum before the collision, the momentum before collision will be equals to, so the momentum after the collision, the momentum after the collision. So that means the momentum will be conserved. The momentum will be conserved. So let's suppose this is a mass which is of initially at rest. So if there is no net force acting on the body, so this bomb which is of mass m, so after explosion it's splitting into m1, m2, m3 parts. So let's suppose its velocity is v1, its velocity is v2, its velocity is v3 after the explosion, because those parts will move right after explosion. So initially it is at rest, which means, so the P initial of the system is 0, so then the P final also should be equals to 0. The P final also should be equals to 0. That means we find their momentums and will be we equate it to 0. Clear guys? Understood? So we'll solve the question so that you'll get the idea. Okay, so just this is a basic concepts. Let's solve the questions. So the question number 4, what's the question number 4 says? See here, a bomb of mass 30 kg at rest explodes into two pieces of mass 18 kg and 12 kg. So the 18 kg of mass, 18 kg mass is 6 meter per second, its velocity. So the kinetic energy of the other mass is, see here. So first try to understand the concept. This is a 30 kg bomb. 30 kg bomb. So now, so it explodes into two parts. So it exploded into two parts. One is of mass 18 kg. And the other one is of the mass 12 kg, right? So the 18 kg one is moving with a speed of 6 meter per second. So initially the system is at rest. Initially the 30 kg bomb is at rest. So that's why the initial momentum should be equals to 0. And there is no net force acting on the body. There are only internal forces. The bomb explodes due to the internal forces in it, right? So there is no net force, right? So then we can say that the final momentum also should be equals to 0. So to conserve the momentum, so what we say, if the 18 kg mass is moving with 6 meter per second this side, so obviously the simple logic is the 12 kg mass should move to this side because its momentum is positive. So this, its momentum should be negative, then only the final momentum comes to be 0. If this momentum is also this side, its velocity is also this side, so its momentum and its momentum will be added, right? So the net momentum will not be equals to 0. Understanding the logic? So that's why if 18 kg mass is moving 6 meter per second to the right, so then this should move with some velocity to the left, or we don't know 6 meter per second to which side. So what you can consider is you can take this side, so then 12 kg mass will move right side. That's it. Understanding, guys? Clear? So from here, so I can write, so the final momentum, what is the final momentum? 18 kg into, so 6 plus, so let's suppose the 12 kg one is moving with v velocity. So let me consider the sign convention, right side positive. Okay, so 18 into 6 plus 12 into minus v I am taking to the left side is equals to 0. So from here 18 into 6 is equals to 12 into v. So 6 ones are 6 twos are 2 ones are 2 nines are. So v is equals to 9 meter per second. So this is a velocity of, so the second one, but they are not asking the velocity, they are asking the kinetic energy of the second mass, other mass. So how do you find the kinetic energy? So the kinetic energy of the other block is equals to half mv square. So what is its velocity? Half mass is 12. So what is its velocity? V square. So which is 81. So this is 6 times. So this is 648. So 486 joules. So option 2 is the correct one, guys. Understood the concept? And you can see that here 18 into 6 108 and 12 into the v, which is 9, so 108. So its momentum is 108 right side and its momentum is 108 left side. So the momentum is conserved, we can say. Understood the concept now? This is just the one dimensional one. So still we have to do two dimensional thing. Done? Clear? Chal. So let's take one more question. So what's the question says? A stationary particle explodes into two particles of masses m1 and m2 which move in opposite directions with velocity v1 and v2. So there is a stationary particle which is of mass m. It explodes into two particles which is of mass m1 and m2. So they move in opposite directions. They move in opposite direction. Let's suppose this is moving with some velocity v1. So then this moves with some velocity v2. So then the ratio of their kinetic energies. So the ratio of their kinetic energies. So I can say that simply. So initially this capital M mass is at rest. Initially the capital M mass is at rest. So if it is at rest, so the initial momentum of this will be equals to 0. The initial momentum of this will be equals to 0. So the final momentum also should be equals to 0. Why? There is no net force acting on the system. There is no net external force acting on the system. Yes? Chalo. Now, so shall I say that, see, so whatever the momentum of this one, so should be equals to the momentum of this. Yes or no? So let the momentum of this one be P1. So the magnitude. So the momentum of this one be P2. So but in opposite directions, that's it. But their magnitude should be same. Yes or no? Its momentum should be same. Then only the final momentum will be equals to 0. So now they are asking the kinetic energies ratio. So we know that the relation between kinetic energy and momentum. So Ke is equals to P square by 2m. The kinetic energy is equals to P square by 2m. So from here, shall I simply say that, so the kinetic energy is inversely proportional to the mass because momentum is same for the both masses. So just 2 is a constant and the kinetic energy is inversely proportional to the mass. So therefore we need E1 by E2. So the kinetic energy of the 1 by kinetic energy of the 2. So simply you can write M2 by M1. So simply we can write the M2 by M1. Option 1 is a correct one. Clear? Understood, guys? Simple thing, simple question. No need to go for the momentum conservation again, finding the velocities and finding the kinetic energies and doing the ratio. So directly you know the relation between kinetic energy and momentum, and their two momentums are same. Just directly kinetic energy is inversely proportional to the mass. Done? Chalo, so let's take the next question. So what's the question says? A shell in flight explodes into 4 unequal parts So which of the following is conserved? So see here, this is the shell which is in air. Flight means which is in air. It explodes into 4 unequal parts. So this is of mass m1, m2, m3 and m4. So then which of the following will be conserved? See, so if there is no net force acting on the body, F net is equals to 0. So if its initial momentum will be 0, and then so these 4 particles combinedly, their final momentum also should be equals to 0. So the only thing that will be conserved will be, so the momentum. Their kinetic energy will not be conserved, their potential energy will not be conserved, because different particles will be at different heights. So therefore their potential energy will be different, and so the different they will have different velocities, their kinetic energies will be different. So we can't say that their potential energy and kinetic energy are conserved. So we can say their momentum is conserved, right? Sure. Simple question again. Let's take the next question. So what's the question says? An explosion breaks a rock into 3 equal parts in horizontal plane. So 2 of them go off at right angles to each other. So at speeds 6 meter per second and 8 meter per second. Find the speed of the third part. So this kind of questions we can solve it by 2 methods. So I'll tell the first the procedure long method, then I'll tell the shortcut simple procedure. So we'll solve by 2 methods. The first method, method 1. Try to understand the question. So an explosion breaks a rock into 3 equal parts. So let's suppose this is a rock of mass capital M. So this explodes into 3 equal parts. 2 of them go right angles to each other. So 2 of them go right angles to each other. So if this goes at a speed of 6 meter per second, and then so this should go at a speed of 8 meter per second, because they mentioned at right angles to each other. After explosion, one is moving in x-axis, the other one is moving in y-axis. Now the third mass is also there. The third, this is of mass m, this is of mass m, and this is of mass m. So now the third one also should move. In which direction the third one should move? Tell me. The third one should move, compulsory it should move in this direction. Why, sir? Why? Because so its initial momentum, its momentum will be this side and its momentum will be this side. So they combinedly their momentum will be along this. Yes or no? So their momentum, so combinedly these two, so their momentum will be this side. Yes or no? So its momentum and the third particle's momentum should be cancelled, because the initial momentum of the system is equals to 0, right? Pi is equals to 0. Yes, Pi is equals to 0. So the P final should be also equals to 0. So if the P final has to be 0, P final has to be 0. So then the resultant, see here, the simple logic. Here momentum mv. So what is the momentum of this? You can write like this. So the momentum of this is 6m. So the momentum of this is 8m. So compulsory. So its momentum should be, the resultant will be this side. So and the resultant and this one should get cancelled. That's the logic. That's it. So but let's do by the procedure first. So let's suppose the third one is moving with a velocity v this side. So then it will have 2 components. So let's consider. So this angle I am taking it as theta. Which angle will take theta? Any angle you can take theta. So then we can write. So this side its momentum will be mv. Yes. So then mv cos theta will come this side, and then mv sin theta will come this side. Yes or no? Its momentum is mv, right? So mv cos theta and mv sin theta. So now horizontal and vertical equilibrium you can consider. So mv sin theta is equals to, so this momentum will be equals to 8m. Yes or no? So its momentum will be its mass into velocity, 8m. And then so mv cos theta is balanced by, mv cos theta is balanced by 6 into m. 6 into m. So you can cancel mm, you can cancel mm. So here v sin theta is equals to 8, and then v cos theta is equals to 6. So then simply you can to find the v velocity. So what I am doing is, let it be equation number 1, let it be equation number 2. So let's do one thing. So square it on either side. Let me add the new slide. So now see here. So I can write, so mv So not m cancel, right? V cos theta, V sin theta is equals to 8. V sin theta is equals to 8, and then V cos theta is equals to 6. So then let it be equation number 1, let it be equation number 2. So now I am doing 1 square plus 2 square and adding those two. So which is nothing but V sin theta whole square plus, so the second one V cos theta whole square. Their LHS adding and squaring. And then so they same, so 8 square plus 6 square. So this becomes, so here we can write V square sin square theta plus, so V square cos square theta will be equals to, so 64 plus 36, which is nothing but 100, right? From here, so you can take out V square common, which comes out to be the sin square theta plus cos square theta, so which is equals to 100. From here, this value we know that 1, so therefore V square is equals to 100. So from here, so the V is equals to 10 meter per second. The V is equals to 10 meter per second. That's it. Understood, guys? Clear? So that means the third particle should have the velocity, so at the 10 meter per second. Option C is the correct one. Understood? This is the long procedure. So but you can consider the method 2, which is the simplest one. See, in sometimes the question they may ask at what angle also. At what angle also? How do you find the angle here? So the tan theta is equals to, so you can write mv sin theta by mv cos theta. Yes or no? So the tan theta is equals to, so this by this. You can find their values. We know the values, so you can just substitute and get the theta value as well. Right? Chalo. So now, so the method 2, the simplest procedure. Understand carefully. See, this is of the mass m and this is of the mass m. So it is moving with 6 meter per second, and then this is moving with 8 meter per second. Now its momentum will be 6m and its momentum will be 8m. So what will be the net momentum of these two? So the net momentum of these two will be square root of 6m whole square plus 8m whole square. Yes or no? So which is nothing but, so m square, m comes out, and then 10m will be there. Yes or no? Why? Because 6 square is 36, 8 square is 64. So 64 plus 36 is 100. Root 100 means 10. And m square if you take out, so m will come. So therefore the net momentum is 10m. And the third particle should move. The third particle is also of the equal mass. In the question they said they are equal parts, right? So it is also of mass m. So obviously it should move in such a way that it should cancel out, so the net momentum of these two, right? So that's why, so we can say that the mv, its momentum mv is equals to, so the net momentum of these two, so which is 10m we got, 10m. So here m cancel, so simply the v is equals to 10 meter per second. Direct question. Simple method this is. Understood? Clear, guys? Chal. So let's move further. So this is done. So let's move further. So let's go for the question number 8. So what's the question says? An explosion breaks a rock into 3 parts in a horizontal plane. So 3 parts. So 2 of them go right angles to each other. The first part is of the mass 1 kg, moves with a speed of 12 meter per second. The second one is of mass 2 kg with 8 meter per second. And if the third part flies with 4 meter per second, so then its mass is, see here. So first, a rock which is of some mass m, so which explodes into 3 parts, not equal parts. So this time, so one is of sorry guys, mass 1 kg, the other one is of mass 2 kg. So this 1 kg and 2 kg, they are moving right angles to each other. So 1 kg is moving with 12 meter per second this side, let's suppose, and then so this one is moving with a speed of 8 meter per second this side, right? So now you know that the third one should move to this side. Yes or no? So what will be the net momentum of these two? What will be the net momentum of these two? So I can directly write the momentum of this is 12 into 1, 12, and then the momentum of this is 8 into 2. So 16 is the momentum of this. Yes or no? Mass into velocity. So here also mass into velocity, 12 into 1, so 12. So therefore the net momentum of these two will be square root of 16 square plus 12 square. So which is nothing but, so total how much we get? 144 plus this is 256. 144 256 means 400. So 400 means this is 20 we get. Yes or no? The net momentum of these two is 20. Now its mass is, we don't know, we have to find, and its velocity is given how much? 4 meter per second. So now we know that its momentum and the net momentum of these two should be equal, because the initial momentum of the system is 0, the final momentum of the system should be equal 0, because there are no external forces acting on the body. F external 0, right? So that's why the net momentum of these two is 20, must be equals to, so its mass into the velocity 4, right? So from here the mass is equals to 20 by 4, 5 kg. Simple question. So for the system of three particles, if an object breaks down into 3 parts, so 2 of them are going right angles to each other, and the third one should move in such a way that the net momentum of these two should be cancelled by the third one. See here, these two are going right angles to each other, so the net momentum will be in this direction, right? Yes or no? So then the third particle's momentum should be exactly in the opposite direction. So that's the logic you should understand. So then you can solve these questions very, very easily. So let's go for the question number 9. So what's the question says? See here. A 1 kg stationary bomb so exploded into 3 parts. So total, this is of 1 kg mass. So it is exploded into, stationary bomb means it is initially at rest, which means its initial momentum is 0, because it is a stationary bomb. Yes or no? Yes, fine. Now, so into 3 parts of mass, so 1:1:3. That means if it is of mass m, and this is of mass 3m. Yes, so then 3 parts. So parts having same mass move perpendicular direction. So see here. So 2 parts are having same mass. So this is of mass m and this is of mass m. Yes, so they move perpendicular direction like this. So with a velocity 30 meter per second each. This is 30 meter per second and this is 30 meter per second. And then the velocity of the bigger part will be, so the bigger part means this is a 3m. This is the 3m. So we need this velocity. So how do we find the same concept? So you can simply proceed like, so its momentum will be 30m, mass into velocity. Its momentum will be mass into velocity 30m. So that their net momentum will be square root of 30m whole square plus 30m whole square. Or else you already know this. So when 2 equal masses are there, so then the angle between them is, when 2 equal forces are there and the angle between them is 90 degrees. So obviously, so their net will be 30m root 2. Yes or no? 30m root 2. We already studied it in the NLM, right? So this is our force F, this is our force F. The net force will be F root 2. So here 30m and here 30m. This is going to be 30 root 2. And then, so this one, the third one should move opposite to this, because the momentum should be conserved. So 3m into the velocity v. So now you can simply solve this question. So 30m into root 2 is equals to 3m into v. So the net momentum should be equal and opposite. So m cancel. So 10s are, so then v is equals to 10 root 2. So the velocity of the bigger part is 10 root 2 meter per second. Understood, guys? Clear the concept? Chalo, simple questions. So just whenever a bomb breaks into 3 parts, 2 of them are going right angles to each other, means first find their net momentum, and third part should move opposite to their the resultant of these two. So like this. So then the final momentum will be 0. Clear? Chalo, so let's solve the next question. So what's the next question says? A particle of mass 5m which is at rest suddenly breaks. So which is at rest initially, this is of mass 5m, which is at rest means its initial momentum is 0, right? So breaks into 3 fragments. So 2 fragments of mass m. So one is of mass m and the other one is of mass m. So each move along mutually perpendicular with the speed v each. So this is moving with speed v and this is moving with speed v, right? So then there is one more mass will be there. What is the other mass? Obviously 3m, because the total mass is 5m, right? So if each of them is mm, so the third should be 5m. Now, so the energy released during the process. So they are not asking what is the velocity of the third one. They are asking the energy released. See, as the three are moving, what kind of energy they possess? They possess the kinetic energy. Yes. So the total energy released in this process will be the kinetic energy of the first mass, the kinetic energy of the second mass, and the kinetic energy of the third mass. So we know the kinetic energy of the first mass because we know its velocity. Second mass also we know its velocity, but we don't know the third mass velocity. How do we find velocity? Just the conservation of linear momentum. So initially it is at rest, momentum is 0. There is no net force acting on the body. So the final momentum should be equals to 0. So here the resultant of these two momentums, its momentum is mv and its momentum is mv. So the resultant will be mv root 2. Yes or no? So then let's consider, so its velocity be 3m into, let its velocity be v dash, because already the v and v are there. Let its velocity be v dash. So then its momentum will be 3m into v dash. So then 3m into v dash will be equals to, so mv root 2, mv root 2. So from here m gets cancelled. So then v dash is equals to, so v dash is equals to v into v by 3 into root 2, v root 2 by 3. This is a v dash. Yes or no? Correct only, right? mv root 2. So 3m into v dash. So 3m into v dash is equals to mv root 2. So from here m cancel. So v dash is equals to v by 3 into root 2. Yes, fine. So now what they are asking in the question? So what is the total energy released? So what is the total energy released? So therefore the total energy released will be equals to, the total energy released will be equals to, so the kinetic energy of the first one plus the kinetic energy of the second one plus the kinetic energy of the third one. First one, second one, and third one's kinetic energy. So first one has the velocity v, so that's why half its mass is m, its velocity is v square. So its velocity is v, so v square. So right, formula, as per formula. So then second mass, half its mass is m, velocity v, so v square, plus the third one, half its mass is 3m, the third one mass is 3m, and its velocity is v by 3 root 2 whole square, v by 3 root 2 whole square. So from here, so we get half mv square plus half mv square is mv square, combinedly these two, plus, so this is half into, so 3m into, so here v square by 9 into 2. So here 2 cancel, root 2 whole square is 2 kada. So 2 cancel, ikkada 3, sorry guys. So here 3 ones are 3 guys, 3 times. So then mv square plus, here it is mv square by 3, right? 1 plus 1 by 3, which is nothing but 4 by 3 mv square. So the total energy released in this process will be 4 by 3 mv square. Done? Clear the process? Chal. So let's move further. Let's take the next question. So what's the question says? A body of mass 4m is lying on xy plane at rest. Initially it is at rest. It suddenly explodes into 3 pieces. So 2 pieces each of mass m perpendicular to each other with speed v. So the total kinetic energy generated in this process. Same kind of question. See here. This is of mass 4m. So then it divides into 3 parts. So 2 masses each of 2 parts each of mass m and m. So they move perpendicular to each other with speed v. So its speed is v and its speed is v. So obviously the third mass will be 2m mass. So it should move in this direction. Let its velocity be v dash. So what is the resultant velocity of these two, resultant momentum of these two? Its momentum is mv and its momentum is mv. So the resultant momentum will be mv root 2. Yes. So then, so the mv root 2 should be equals to, so 2m into v dash. Yes. From here m cancel. So now we need v dash. V dash is v by 2 into root 2. V by 2 into root 2. So now we need the total kinetic energy released during the process. So the total kinetic energy will be equals to, so half, the first one's mass is m, velocity is v, so half mv square, plus the second one's mass is m and velocity is v, so its kinetic energy will be half mv square, and the third one's mass is 2m and its velocity is v by 2 into root 2, so mass is 2m into its velocity is v by 2 into root 2 whole square. So now do the procedure, half mv square plus half mv square, which is mv square, plus half, here 2 cancel, m into, so v square by 2 square is 4 plus, sorry, 2 square is 4, and then root 2 whole square is 2, so 2 ones are 2 twos are, so mv square plus mv square by 2, so which is 3 by 2 mv square. Yes or no? So which is 3 by 2 mv square. Option 3 is the correct one. Simple questions, no need to struggle much, right? Hope you guys are understanding the concepts, right? Chalo. So let's move for the next question. So what's the question says? Vector form is given. An object flying in air with velocity, it is actually initially flying in air, so with velocity is given, so suddenly breaks into two pieces whose masses are in the ratio 1:5. So the smaller mass flies off with a velocity, this one, and the larger mass will, the velocity of the larger piece will be, see here. So this is of mass total 6m. Let's consider this is of mass total 6m. So it is moving with some velocity. Initially it is not at rest. It is moving with this velocity. So it's moving with this velocity, right? So which is equals to, which then breaks down into two parts. One is of mass m and the other one is of mass 5m. So if it moves with velocity v1, then so the larger piece should move with some velocity v2. Yes or no? So then its velocity, its velocity should be v2. So now the same process I am going to do it in the calculations. So its mass, total mass is how much? 6m into what is its velocity? Initial velocity 20 I cap plus 25 j cap. Yes or no? Mass into velocity, right? The net momentum from here will be equals to momentum of this one plus momentum of this one. So that's what I am going to do. See here, the net momentum will be equals to p1 plus p2. That's it. So here 6m, its total mass is 6m into its velocity 20 I cap plus 25 j cap minus 12 k cap will be equals to, so the momentum of the first one, what's the momentum of the first one? Its mass is m. So the smaller part velocity is already given. So 100 I cap plus 35 j cap plus 8 k cap, right? And the second one's velocity we don't know. So what is the mass of the second one? 5m into its velocity, let it be v. So now, so let's take out m common and cancel both the sides. So then we got this side 6, if you multiply inside, so 120 I cap plus, so this is 150 j cap, so minus, so 72 k cap, so which is equals to, so this is 100 I cap plus 35 j cap plus 8 k cap plus 5v plus 5v. So now do one thing, send this whole vector to this side, so then 5v will be equals to 120 I cap minus 100 I cap, which is 20 I cap, then 150 j cap minus 30 j cap, so which is 115 j cap. Yes or no? So 150 minus 35, 115 j cap. So here minus 72 minus 8, which is minus 80 k cap. Yes or no? Minus 72, so minus 8 k cap, which is minus 80 cap. So now we need only the velocity. If you send 5 to that side, so 20 by 5, 4 I cap plus, so this is 2 times, 5 2 times and 5 3 times. So this is 23 j cap. Yes or no? So then this is going to be 5 1 time, 5 6 times, so 16 k cap. So the velocity of the larger piece will be in the vector form, this one 4 I cap, the first option is not there, so 4 I cap plus 23 j cap minus 16 k cap. Yes, option 2 is the correct one. Done. Simple procedure. Initially it is not at rest, that's why its mass into velocity must be equals to the momentum of the other two parts. That's it. Clear? So let's go for the next question. So what's the question says? a mass of 1 kg thrown up with a velocity 100 meter per second. So this is a mass of 1 kg. It is thrown up with 100 meter per second. So its initial velocity is 100 meter per second, thrown up with 100 meter per second. So then, sorry guys. So 100 meter per second. Then after 5 seconds, it explodes into two parts. See here, after 5 seconds means its velocity changes by the time it reaches here. So then it explodes into three parts here. So like this. So where one part, two parts, sorry, only two parts. It explodes into two parts. So this is one part, this is one part. This is of the mass 400 grams, which means 0.4 kg, and the other mass should be 0.6 kg. So 0.4 kg mass comes down with a velocity 25 meter per second. 25 meter per second. Then the velocity of the other part should be equals to, what should be the velocity of the other part? So this part will move with how much velocity? That's what they are saying. See here. So initially this part is not at rest. This is not at rest because it's initially given 100 meter per second. After reaching, after 5 seconds, what will be its velocity? First find its velocity after 5 seconds. So 1 kg body's velocity after 5 seconds. After 5 seconds, which will be equals to V is equals to U plus AT. So what is the final velocity? We have to find its initial velocity 100. So an acceleration is minus 10, and then time after 5 seconds. So 100 minus 50, 50 meter per second. So that means after 5 seconds its velocity is 50 meter per second. Right? So 50 meter per second is its velocity, and what is its mass? 1 kg. So then its momentum will be equals to, the net momentum will be equals to, so the momentum of this one plus the momentum of this one. That's it. So now do the calculations. So what's the momentum of the P net? Will be equals to P1 plus P2. So obviously, so the first one, what is its velocity, momentum? Mass 1 kg, velocity 50 is equals to, so the P1, so the momentum of this one 0.6 into, so it should move upward. Yes or no? It should move upward, and then the other part is moving downwards. So its mass is how much? 0.4, and its velocity I am taking minus 25 because it's moving. They clearly mentioned it comes down, right? So that's why 50 is equals to here 0.6 means 10, 6 by 10 V plus minus 0.4 means 4 by 10 V, 4 by 10 into 25, right? So from here, let's do one thing. So 4, or else shall we cancel or send it to this side? This is 500 is equals to 6V minus, so this is 100. Yes or no? So from here 6V is equals to 600. From here the V is equals to 100 meter per second. So the V is equals to 100 meter per second. So the correct option is option 3, guys. Understood? 100 meter per second upward. Done? Clear? Everyone? Chalo. So that's it from my end, guys. So this is all about the conservation of linear momentum. So in the next session, we'll start with the collision concept. So under this chapter itself. So collisions, for collisions, I'll take some 2 to 3 lectures. So with that, the collisions also will be done. Next, we'll start the rotational motion topic. So till then, keep studying. All the very best. Bye. Take care.